Hi everyone, this is Santosh Kumar. Welcome back to next training. Today we are going to continue exploring the assembly workbench. Today we are going to see some of the tools that are available under the general tab. Uh, we'll start with the wave geometry linker. This copies geometry from other part in the assembly into the work part. So there are other parts in the assembly, and if you want to copy that particular geometry into the work part, then you will make use of this wave geometry linker. Example for this is you have a casted component. So there is a casting component and you want to perform a machining operation on it without affecting or disturbing the original component. Then you can wavelink that cast component into a work part and then perform the boolean operations on that casted component. I will show you for example. Here I have taken this bench vise as an assembly. Now this vise jaw I need to wavelink into the vise body, so I will make this vise body my work part. As you can see, the moment I made vise body, the rest of the components have been grayed out. So here this component I will be pulling it into the vise body as a wave geometry. As you can see here, I'll select the wave geometry linker and I'll be selecting the entire body. I want this entire body. Imagine for example this is a casted component, still not machined yet. So I am going to pull this casted component into my vise body. So as you can see here, now this is not grayed out. So in the work part, if you see, you have a link body that has been linked into the vise body. So here now once I imported it as a wave geometry, now here I can make boolean operations on it. I can make changes to it by giving some fillets, chamfers. So this will not affect the original body. This will only be applied onto the linked body, and you can perform all the machining operations on it. I'll show you the original body as well. So once I open this, open in a window, if you see the original body, there is no fillet applied, but in the wave link, as you can see here, the fillet is been applied. So that's the use of this wave geometry linker. So the other use of this wave geometry linker is you have in case of the routing object. I will come to this in the electrical routing training sessions. So the routing object can be used to select the routing specific intelligence onto the cables. So you can pull those fixture ports into the level of the part in which you are working, and then make the electrical routing, so that there will be an associative between the routing intelligence as well as the electrical routing which you are going to create. So this way even though you try to make a modification in the top levels, eventually those changes will be implemented for the electrical routings as well. So that's the use of this wave geometry linker in case of the routing objects, which I'll be discussing in the upcoming videos. As of now, we will just see an overview on just the wavelength geometry. And next you have the arrangements. This arrangements is actually used to show different positions of an assembly. Say for example, in this case, in the vise jaw, I'll be showing the closed as well as the open position. For this, I'll select the arrangements. I'll rename this to be closed. Initially I'll keep this one as a closed, so I want this to be my closed position, and then next I'll be creating a new arrangement that's open. I'll make this as my active arrangement. Now I'll move this component to this is my open position. Now if I go here and toggle, I can toggle between the open and the closed positions. So that's the use of the arrangements. There are much more uses of this arrangement, which I'll be explaining in the upcoming videos. As of now, this is what happens with the arrangements. And next we have sequencing. Sequence is actually used to create a movie of how exactly a component has been assembled in an assembly. For example, let me go into the sequence, select new. You can toggle to the sequence tab here and then select new, and I'm going to first create a cameras as well as the motions of that components. This is my camera position. I want my camera position. Let me create the camera position, and I want this vice jaw to move to and fro. So I'll select insert motion, select my component that I want to move, and I'll select the move object, and I want to move this by 45 46. So this is my open, and then it closes 46. So I have created one motion that is open and close of the vice jaw, and the next one would be, I'll change this camera position to this view here. I'm going to create another camera position, and then I'm going to rotate this object. Let me select, I want all these components to be rotated. I'll select all the component, and I'll select the rotation to be 360. This is my end camera position, and I'm going to end the simulation. So I'm going to close this one. After the tick button, I'm going to close this, and I'm going to rewind it, and I'm going to play it. So initially, so this way you can create a number of sequences according to your requirement. That is the use of sequence, and then click the finish button. You'll come back to the originals. So that's the use of sequence. Next we'll look into the exploded views. Explode views is used to show the exploded version of the assembly that you have created. So once you go into explode, you have new explosion. Select the new explosion. You can give it a name according to your requirement, and once the name has been created, later on you can go edit this explosion, and you can select the component that you want to explode. This is a manual way of explosion, and you even have auto explosion. You can select all the components that you want to explode, and then click OK, and it's asking what is the distance to which you want it to be exploded. I will give it as 100 and select OK. As you can see, all the components have been exploded at a distance of 100 mm. But if you feel like this automatic explosion is not working out, you can manually explode with the edit option. You can go here, you can select the objects. Say for example, in my case, I want this one to go above, not below the vice body. So I will select the component, and I will move it with the handle. I'll move the handle above. I want it to be in this position. So this way you can manually create the explosion and save this explosion. And under this explosion, that's the use of this edit explosion and auto explosion. We have seen it. And you want to hide a particular component in the window while exploding, then you can make use of this hide component in view and show component view. Show component view is used to show, and hide component view is used to hide. And you can delete the explosion. If you don't want a particular explosion that you created, you can delete the explosion. That's the use of this delete. Now for example, I don't want this component to be visible in my explosion. I will select that component, go to hide component, and tab opens. So you can select all the components that you don't want to show. Say for example, I'll select these components. I don't want it to be visible in my explosion, so it will hide those components, and only these will be saved in the explosion. So this explosion view can be pulled even in the drawing later on. And if you want to show the component, you can select all the components that you need to show. Select OK, and all the components will be visible back. And you even have the option to show the trace lines. The trace lines are actually used to show how exactly components are getting assembled, or the path along which the components move. For example, in my case, I want this bolt to be inserted inside this component, so I'll select the point. So I want it to specify the start point here. So from here to here, select OK. As you can see, this is the trace lines, and the same will be shown in the drafting. So you open the drafting, the trace lines will be visible to you, and here also you can show the trace lines. Select the trace lines. So the cylinder moves inside the hole. So this way you can show the trace lines. So this way you can make use of the trace lines. So that is the use of the trace lines. And this is unexplode, opposite of explode. You want to unexplode a particular component, you can make use of that. You can select the component, select OK, it will come and sit in the respective positions. That's the use of the unexplode. So today we have seen the wavelength geometry, arrangements and sequence, and explode view. Next up we can see the clearance analysis. Clearance analysis is used to detect the interference, whether it is a light interference or a hard interference can be detected with the help of clearance analysis. So if there are objects here and you want to know whether they are interfering with the neighboring object, then you can make use of this clearance analysis set. You can even go to that from menu and analysis, and simple interference and assembly clearance is there. From here you can go to clearance set. You can select the set. This way you can go to clearance analysis, or directly you can go from here, select create a new set, click OK. So it will show you all the interference that it encounters between the components. So if you see, the screw jack is having a hard interference, so you can even see where exactly the hard interference is happening. So all these three are having hard interference with the neighboring component, and the rest are all having just touch interference. So I'm okay with this. I can acknowledge this and I can okay with it. But these three are having hard interference. This I need to fix. You need to find where exactly the hard interference is happening, and you can fix those interference. If you see, in this case there is a hard interference that happens at study interference. You study the interference where exactly it happens. So if you see here, there is a very, once again you can study this interference. It is highlighting with the red color outline mark, which says that this is the region where the hard interference has been happening. You can even go to the view and see through. Yeah, as you can see here, the red line indicates that that is the region where the hard interference is happening. Initially, if you see for this, in this region the hard interference is happening. If you want to fix, you can fix it. Again, in the third one, study interference, the hard interference is happening at this place. So this way you can make use of this clearance analysis. So that's the use of the clearance analysis. Clearance analysis would tell you where exactly the hard interference is happening, and along with that you even have, under the analysis, you even have simple interference. Simple interference would directly give you the data where exactly the interference is happening, and you can manually select the two components between which the interference is happening. The first body is this and my second body is this, and you want the resulting object to be high latent phase or interference body. Do you want to create a body of that interference? You can select the interference body, select OK. Now if I hide this two objects, see, this is the interference body. So this is the region that has to be fixed to avoid the interference. So this way you can create simple interferences. Again, you can go into the analysis, simple interference. Now I don't want the body to be created, I just want to be high latent. In that case you can highlight in the face, first face, so it will highlight in. So you can go to the view, see through. So as you can see, it is just highlighting the faces where the hard interference is happening. So this way you can find and resolve the interferences. Next we'll see into the move component. Under move component you have collision detection and some of the settings available here. We'll see how exactly these things work. So initially there is no object between the vice job. So under move, first let me check whether there is a collision that's happening between these two jaws. So I will stop before collision. So in steps of 200, I will move this by 46. So I'm not encountering any collision in the open position. Well, in the close position once again. I'm still not encountering any collisions. So now what I'll be doing is I'll be introducing a block between these two jaws, and I'll see how exactly this collision finds the collision. So for that I will add a block between the jaw. Select the block. As you can see, there is a collision over here. So exactly at 20 mm there is a collision which is happening between the block and the jaw. So this way the collision detection is very useful. This is stop before collision. So if at all there is a collision at that particular moment, it will stop and it will highlight the objects which are getting collided. And if you select highlight and collision, it will highlight, but still the jaw would try to move forward. For example, in this case, once again I'll run the motion simulation. As you can see, now there is still no collision. 46. As you can see, it is just highlighting the objects that are getting collided, but still the jaw is moving into the block. That is because you selected highlight collision. So highlight collision would will just only highlight in the collisions that's happening, but stop before collision will stop the object and it will highlight. So that's the use of this collision detection. And you can even save this into the arrangements. You can click apply to used and select OK, and this particular arrangement would be saved in the arrangement. So that's the use of the move component. So if you like this video, hit that like button and share max. Until then, bye. Santosh Kumar signing off.